All right, I think we're going to get started. I think we got a few people still trickling in, but it'll be a great opportunity now to begin the second part of our discussions. And I'm kind of using two mics here. Let's see which one we like better. All right, can you hear me with this one? Yeah? All right, it's good. Let's do that. Here's how we'll do it. I am going to tell you a little bit about what I heard out of this and some themes that I got. And we're going to have a little discussion with the panel. And then we're going to throw it out to you for your questions to the panel. Now, what you have here, I've done stuff with the National Academy of Engineering for some years. This is a very unusual panel in that it's sort of across disciplines, and it's really everybody's view of the future. And it's sort of, as I was sitting listening to it, made me understand that when we talk about the future in the news business, we often do that. We think about what the future is going to be, but it's so interesting. Each of you took your slice in which you work and you think about the future from that perspective, and it's remarkably important and accurate within that slice. Any of you could talk to anybody in the world about the future and it would seem entirely complete and accurate. But Arun, when you're talking about energy, one will think that without the situations you put forward, the world will be eliminated as we know it. Bob, same thing with you. You put things forward that suggest we'll be done if it's not done right. Leonard, we can't imagine. I mean, most of us from popular culture think about the world that you put forward. Coralie, you were very artful at not discussing the fact that things from the earth are really central to all of our discussions right now, the preservation of the earth and what we can draw from it. Wanda, yours is really interesting because we're dealing with the things that make kids want to be engineers in many cases. We're also dealing with tensions between, not tensions, or how we think about government and private enterprise and how they come together to create our world of space. I'm a pilot, so I really enjoyed listening to everything you had to say, Robert. And Rod, I would say that at some point in our life we can sit there and say, that's interesting, the stuff you have to do with, until we all need it. And then we're really interested in the hyper-specific parts about what exactly we're able to map out. So all of this kind of appeals to all of us, and there are sort of cross currents across it. And I sort of think that some of you work in fields where integration between universities and the private sector and governments was really, really important. Some of you worked in places where people were way out there and just decided to try things that no one would have thought of it. Some of it is motivated by national security. Some of it is motivated by private money. And increasingly in this world, and I've been in this auditorium with a bunch of people in the past who represent that new element of innovation in America. It's not that new, but the untrained, unmoneyed, uneducated, unschooled people who invent stuff. And because of the internet and the power of computing in our handheld phones, are actually able to do that. So we have this world that's going to look different, not just because of the plans that people are working on and the things that they're working on right now that'll come to fruition. I'm very interested in that. Some of you hinted at it. You hinted at things we're doing now and what it'll look like. But I'm sort of interested in what that X factor is of the people we don't know about, the people we don't know what they're working on, the kid who's dreaming right now who has no particular formal training but has the internet, the kid in some place in Africa or in Asia who's going to get the internet pretty soon on a smartphone, who's going to discover something. And there are enough cases of this in the world that it is an X factor. There's something there. Now, the question is, do we educate these kids? Do we figure out a way to get them into the system? Or do we somehow harness the power that they've got outside of that system? I know here, this is a group of people who've spent a lifetime on education and research, and this is a little bit weird, but some of you will remember having Sal Khan and others up on this stage talking about people who, once they get access to information and they can learn things, challenge the traditional notions of how you educate engineers and how you change the world. One of the things that Dan was sort of just talking to me outside is that this is going to be recorded for history. And the 50th anniversary is going to be something that's going to be looked back at in 25 years or 10 years. It'll be looked back in 50 years. And all of these discussions and your questions are going to represent what we collectively thought the future will look like. And in my business, when we do this, we're just prognosticating. In your business, when you do this, you're actually making some decisions in some cases. You are influencing thought. You are letting people know where they should be studying, or you are letting corporations or governments or universities know where you think their money is best spent. So I want to kick off the discussion there, because you are influencers. This isn't just a, for me, this is just talk. For you, you've got some influence here. So I want to start with Wanda. I can say anything. I can say the world's going to be pink in 50 years. It wouldn't make any difference. But Wanda, let me start with you, because in the last 20 years or 15 years in space, we've had a lot of changes. We've got the end of the shuttle program, which the criticism that's closest to my heart is the number of scientists and engineers that came out of the idea that they wanted to go into space, and what have we got to offer them. We have things, and the president will always tell us, we've still got Mars. It doesn't sit in the same place in one's imagination. So I want to talk about that. But more importantly, I want to talk about the role that private innovation has had and what the future looks like with respect to how much the government should be doing and NASA should be doing, and how much we depend on things like the X Prize or individual investors and innovators in the space. How does it look different? And what's the mix that we best need to get to a future in space that's as exciting as the past that we've had in the last 50 years?
So, not an easy question, Ali. You've touched on a lot of things, and let me just say, one of the biggest change agents for us is the access that people have to information, and the fact that they can see the innovations that are going on all around the world as they're happening. If you think about the Engineer for You video contest, it was not limited to people who had experienced engineering or who had even met an engineer, but yet and still, as what they envisioned engineering to be, they were able to create short stories about that and put it out there for others to see. So I think the access has significantly changed and will continue to change at a rapid rate going forward. The vision of what's exciting, John Kennedy said, let's go to the moon, not because it's easy, but because it's hard, but it teaches us great things and it gives us the opportunity to be innovative. I think there are other areas that we haven't explored. And as we go to space, we have the opportunity to learn more about our own planet, what the limited resources are here, and what are the smart things that we need to do, and what are the investments that we need to do. But it's not just government dollars that create those opportunities. Now you have commercial enterprises that are figuring out ways to leverage and have new businesses that come from space. When we talked about Teacher in Space before, it was putting someone in space to talk about what we knew already here on Earth. In the future, it will be having people in space teaching us about space and about our galaxy and things that we don't know, and whether there are life forms elsewhere. So I think the opportunity for engaging everyone is significantly enhanced going forward, and I think the opportunity for the commercial and government marketplaces to be compatible and to leverage each other is also going to be a great opportunity.
Coralie, let's go from space down underground. Your industry never had the same problem that Wanda's does, insofar as it wasn't the thing that necessarily motivated kids. They got into it for a different reason. However, it's a hot space. You kindly mentioned all of those things that we use that come from the ground that we will all forget about in about 15 minutes. But we won't forget about some of the main ones. We won't forget about coal, although half the country would like to immediately, and the only way they can forget about coal is to think about fracking for natural gas, and about half the country likes that, and the other half thinks it's the worst thing that ever happened. But you're now in this interesting space. And for people who study it, it's very unclear where this is going. It's very unclear whether we're moving from one type of space in mining and resources from the earth into another. What's your sense as we go forward and you take into account all of the political battles that are going on, what your discipline looks like?
Well, we're definitely going to need energy. That was pointed out by Aaron. And my view of that is that it's a market force that's driving between shale gas and coal. And as long as shale gas is less expensive to process, then it's going to have to compete with coal. And so coal probably usage in this country is going to decline, but that doesn't mean that coal usage globally is going to decline. In fact, we're exporting coal right now. If you look at minerals, what's happening there is that as we use more and more of the easy stuff to mine and easy stuff to process, what's happening there is the grade of the materials is going down, the mineralogy is changing, and by mineralogy, what it means is that the complexity of what is required to remove the little bits of metal that are there gets more difficult, and that's where engineering is going to be really important, because we have to figure out how to keep a sustainable future. And I know some of you will say, it's an oxymoron to talk about sustainability in mining, but it isn't, because technology and engineering play such a huge role in maintaining our ability to extract these metals and deeper in the earth, lower and lower in grade, more complex. And when you mentioned hot topic, hot space, that's what happens. Because as we go deeper in the earth, of course, temperatures get a lot hotter. But we have to take advantage of that from a technological standpoint, because oftentimes we can get things out of minerals and ore a lot better when it's hot. But we have to be able to figure out how to see these things under the ground. And that is always our problem, whether it's groundwater, whether it's geothermal, whether it's tunneling for corridors for transportation, or whether it's mining or any of these other things. We have to be able to see what we're doing under there, and that's where I see the great innovation technologically and from an engineering standpoint is actually going to happen.
Leonard, if you speak to Paul Jacobs at Qualcomm or John Chambers or GE, as Robert will know, everybody's talking about the future being the Internet of Things, the Internet of Everything, depending on what they want to do. And I think it's brilliant from a marketing perspective, because if we decide that, we're just about got every human connected, now let's get everything connected. But they sell this well. They sell it from a perspective of more efficient retail, more efficient inventory, safer bridges, greater national security, the ability to take these cameras we've got all over the world and actually connect them so that when you have Amber Alerts or terrorists, you can find them. Give me your sense of whether that's corporate hype or that's really the future of the Internet.
Well, certainly the Internet of Things is happening, as I mentioned. As I said, I'd like the Internet to become invisible. By that, I meant it should disappear into the infrastructure, and the Internet of Things with sensors and actuators and logic and memory in the walls, in your fingernails, in your eyeglasses, in your table, inside your body, are all part of that. But the traffic on the Internet is generated not so much by humans right now. It's generated by software agents and embedded devices. And most of the traffic is generated by those automatic systems, which do a number of important things. You mentioned sensor networks. That's a critical area, and it's very important to realize the benefits we can get from that. The other aspect of the invisibility is that the interface, the human-computer interface, the human internet interface should be far simpler than it is now. It's far too complicated. Typing on tiny keyboards, understanding syntax and the way every app works differently is madness. There should be a far simpler interface. I don't have the solution to it, but that's certainly an important research and development domain. So the answer to your question is yes, it's happening, it's big, it's going to become even more dominant.
What's the thing you use to articulate it? Because depending on what field people are in, they say, here's why the Internet of Things is going to change your life or the world as we know it. What are the key benefits you see?
Well, I mentioned sensor networks as one important domain, but the general concept is this room should be alive with technology. It should know I'm here, it should know we're all here, and if I have a conversation with Carly here, it should assist us in that conversation. It should understand what we're saying and understand our background. So the idea of making it the environment aware, everywhere aware, is, I think, one of the major benefits we're going to get.
All right. Bob, when you were talking, I thought a couple times about artificial intelligence, and I even thought about Ray Kurzweil and the singularity. And, in his mind, we're less than 50 years away from the intersecting of the mind and the computer and what that's going to mean. I've never really fully understood this. Do you share that sort of view that artificial intelligence ends up, and just actually following very conveniently from Leonard's conversation, I mean, if Ray were here, he'd say not only will he know who we are and that we're having that conversation, but in fact it's because we'll all have sort of merged and melded into one.
I think he's full of it, I was going to say something about what you asked Len about. I had this proposal years ago that they should pass a law that every dog had to wear a dog cam and equipped with GPS. And then when anything's happening anywhere in the world, you tune in on the nearest dog, to see what's happening. But, I'm not really worried about this singularity, and I think he's making a lot of publicity out of it. But I just don't see that. I don't think we begin to understand the complexities of the human mind. And when I say machine intelligence, I really think that we'll have machines that are doing a lot of things that people do today and understanding a lot of things. And sure, they can win at Jeopardy and stuff like that. But I just think human beings have something that the machines aren't going to have this next century. Who knows past that?
So let me go to you, Rod, in that case, because you started to draw pictures that looked like the mind as computer. What's your sense of clearly our understanding of computing has helped us understand the mind.
Well, it certainly has helped us to understand some of the structural features. But one of the real challenges and in this area, which is also one of the grand challenges of NAE, as you know, is reverse engineering the brain. And that, I think, is obviously a daunting challenge, and one where computers can certainly play a role. The kind of images that I showed you are a stepping stone, but we have so much farther to go. We understand something about the structure of the brain. We're beginning to see something about how it is wired. We really don't understand how it computes. And we, beyond that, don't have a handle on where emotions come from, where feelings come from, and behavioral health. In the past, we've thought, for example, that depression was really a function of the level of neurotransmitters. I think that perception is beginning to change, and we realize it's more complicated than that.
Arun, let me go to you. You talked a lot about energy. Fascinating conversation. And in fact, for the first 3 minutes of your conversation, I thought you were going to come to the conclusion that we're done for. Then you turned it around nicely. Thank you. But you made no mention of nuclear energy in your presentation. Talk to me about that.
Well, I had a few more slides, but you didn't allow me.
Oh. It's always the 76th slide that had the answer.
Seriously, I can't imagine us addressing climate change in any focused way without having nuclear. I think it's very hard to look at baseload, carbon-free baseload, and I think baseload is important unless we work some real magic on the grid. And so the question is, okay, what do we do about it? We had Fukushima. Germany has gone off nuclear, which I think was a knee-jerk reaction in many ways, political reaction. In the United States, there is a financing issue with nuclear, which is why we're going to small modular reactor, because the capital exposure is much lower. The cost has to come down, because it has to compete in the market. And the cost of nuclear electricity has to come down. If we could just take today's nuclear power plants and extend their lifetime in a good way, the marginal cost of electricity production actually is quite low. Then the issue about nuclear waste, and which is a significant problem in the United States, and we had a Blue Ribbon Commission that put together a report, and I hope at some point there's an amendment to the Nuclear Waste Policy Act where you could actually resolve this issue, because otherwise it's stuck. But if I were on a utility, I'm not in a utility, but if I were to think about a utility and look to the future 20, 30 years from now, and you have to plan that way, you got to hedge your bets. And I would think very seriously about nuclear. You have to.
Well, we'll have to solve that within 50 years, because now we've got on-site storage of nuclear waste, and apparently the things that store it don't last 50 years. So at some point in the next 50 years, we'll be having that conversation for sure. Please be around for that, Arun. We'll call you.
He'll help me.
Robert, I want to ask you, I was fascinated by watching the evolution of those engines, and you're talking about the materials and the weight and the fuel efficiency and and of course, power output. Remarkable advances. Should we be thinking about aviation, which remains crucial, somewhat expensive, but necessary, and certainly one of those things that's happened in the last 100 and some odd years that's been so important. Should we be thinking about propulsion for commercial airlines in a different way? And I'm sure you do. What's the other way of thinking about this, as opposed to engines and their heat and their weight and their fuel usage?
Well, of course, those of us in the business of supplying the engines to companies like Boeing and Airbus, we work partnership with them, and so they kind of set the roadmap for the direction that they would like to go in it. But it's an iterative thing. I did hint that there's a lot of innovative ideas for what the airplane of the future, what it would.
Just talk a little closer into the mic.
Okay. Okay, is this better?
Yeah, much.
I did hint a little bit about some new ideas about having a number of fans along the leading edge of a wing. It would totally change the way the airplane looks, the way it's designed. So if that's what you mean in terms of the configuration.
You showed us, on that slide, you showed us an engine that was essentially developed in and around the 70s that has been evolved and is still, as you said, an engine we use today in lighter form, in more fuel efficient form. But it does seem that for such an important thing, we're still thinking about it in the same terms that we thought about it in the 60s and 70s. I mean, should we be thinking about parabolic flight, for instance, where we're going up and ending up down in 3 hours from New York to Sydney?
Okay, on the supersonic. Oh, yeah.
I'm just wondering what's practical and what's being thought of.
Yeah, we thought a lot about a supersonic airplane, and is there a real business case to go do that? I think if we wanted to do that, we do know how to do that. We could roll up our sleeves. It'd be very costly, though, and it looks like the direction would be for smaller jets, more of the personal jets, for the high-end customers who really need besides the Air Force, who really need to get someplace in a hurry. we do know how to do that. I didn't talk at all about the military jets, because that is pretty interesting, but you had to get the right approvals, to talk about the details.
You could tell me, but then you'd have to kill me.
So the future is supersonic flight. You could say, will it be economical in 50 years? I mean, that is an intriguing possibility, and those of you, have to travel to Asia or to Australia would certainly like that, right? So it's inevitable. It will come. I don't know if it'd be within 50 years, though.
Right.
But that would be fantastic.
I am going to invite our panelists to ask of each other if they have any questions or they want to challenge their views. There's a little bit of overlap between some of you, but I am going to now ask those of you out there to go to the mics. We have one over here and one over here. Please go to them. I'll alternate between them. Won't pick any favorites, and we will have your questions answered. Do you have any questions of each other for right now?
I just have one comment on the Internet of Things. Since I was at Google till about 5 weeks ago, and we bought Nest, and for a lot of money. And this is I suppose, a simple example of a thermostat. Forget the looks, if you may, for the time being. But it's cloud connected, and I think all homes will be cloud connected, all cars will be cloud connected. And through the cloud, it interacts with the utility, or for that matter, independent system operator, to reduce the load when someone has a demand for it. And I think this is a simple example where it provides value. And I think there would be other examples of that as well.
It certainly provides value. I have a few, and I'd like to throw them out of my house. Now, technically it's a wonder, but the damn thing is too smart. And it does things I don't ask it to do, and I don't even know it's doing. And it's hard to undo the brains inside of that. I'm talking like a Luddite at this point. But there's an example of a product which somehow missed the human value.
We need better machine learning. And I think, I agree. I think if you could do my Nest thermostat is also misbehaving because of that. And,
exactly.
Yeah.
Interesting. All right. Let's start over there. Sir, please identify yourself and your section.
My name is Dave DeZonbeck. I'm head of civil and environmental engineering at Carnegie Mellon University, and I'm with Section 4.
I have no idea what Section 4 is, but
Section 4, civil engineering.
Thank you.
Civil engineering.
I just thought I'd have you guys say it.
Civil engineering focuses on infrastructure, private and public infrastructure. My question is for Dr. Majumdar, Dr. Brierley, perhaps others on the panel, about scale of systems and institutional arrangements that affect technology development. If several of you look back at the past century, tremendous advances. Dr. Lucky, among the advances cited in that report were water treatment, chlorination of water, critically important. This is large-scale water infrastructure. Something else that happened last century was the development of our institutions. We developed the science of risk assessment. We engaged stakeholders in much broader ways. And for large-scale systems, that really makes more complex moving technology forward. And so I would ask the panelists, as you look ahead to the next 50 years, how do you see our institutions evolving that relate to development of technologies for large-scale systems, and what kind of advances do we need to do better at moving technology forward in an environment where many, many people now have a voice?
I have one comment about that. As engineers, we've always had the arrogant attitude that the systems we build, we more or less understand. And whereas the natural sciences have had the curse of dealing with a system they didn't create, and they have to figure out how it works and why it works, etc., we no longer have that pleasure, if you will. Our systems are getting so complex, they're behaving in ways we don't understand, don't anticipate, complexity for a lot of reasons, size, interactions, intelligence. And so the issue of complexity that you raise is essential, and I agree in all aspects of engineering. We have to step back and address complexity as an issue in itself.
Please.
So, great question with institution. Just to give you one example on the electricity system, I talked about the Tesla Edison paradigm, centralized generation, long-distance transmission, and then local distribution. So the institutional electricity system also follow that paradigm. So you got the independent system operator who does wholesale electricity, and they have to balance the grid. On the retail side, you got the utilities who buy electricity and distribute to your homes and buildings, et cetera, right? So that the institution also follow the paradigm. Now you're looking at, for the first time in 100 plus years, that people want to put solar rooftop or storage units or whatever that may be, and you got distributed resources, and the loads have to talk to the generation, and generation don't always have to follow the load. The load may be following the generation then, because you got intermittent generation. So these institutions have to now are questioning that. Many of the utilities are trying to figure out how do we manage this transition, and there are possibly new business models, new financing models that'll have to be brought in. But it's a very important issue. So when I talk about the system, it's not just the technical system. It is the institutional system. It is the financing system. All have to be aligned. And it is absolutely critical to manage this transition in the most cost-effective and reliable way.
And the community voice, I would add, which is...
So it's a remarkable point, because when I think of everybody else's areas of expertise here, well, you've got a lot of lobbying and political interests involved, but this is one where the institutions are working very hard in some cases to maintain the status quo. So all that excitement with which you speak is harder to get done in the real world. Thank you for your great question, sir.
Mr. Schwartz, Columbia University. A question for Dr. Austin. Your concept of small satellites is fascinating. But doesn't that raise a lot of questions and problems? For example, how do you keep track of all of them? Secondly, they pose hazards up in space. They add to the junk that's already up there. How do you get rid of them?
That's a good question. We are building, every university is building small sats and CubeSats, and we've got P-pods that we can pop them off and do experiments. But one of the things that we're also doing, which I think is a great testament to engineering, is we're designing them for reentry to minimize the debris that they're creating. We're designing our upper stages so that they are, when we launch them, we know when they will reenter, and to minimize the space debris, because this is a growing challenge for us. And it's a growing challenge for us from a security perspective, because just like we're launching small things, other people are launching small things as well, and it is important to be able to track them and know where they are and know what their functions are. So this is an area where it's rich for continued research and development, and it's an opportunity for, I think, advanced designs in terms of how we make sure that we bring things back safely and do not create lots of hazards in space. So a current challenge that we are living with today, and a current challenge for us, even when we launch a lot of our own small and CubeSats, being able to find them all and track them all and know exactly where they are.
And sir, you win the award for the best question that I could understand. That was excellent. It's like the stuff, you're putting it in space, it's going to crash with each other, and it's too much junk. Love it. Thank you. Go ahead.
So let me try to top his. My name is Marsha Usagi Hames. I'm the daughter of a Section 11 newly inducted member, Dr. Roger Usagi, and I'm happy to be here. My question to you is twofold. The first part of my question has to do, I'd like to direct it to Dr. Brearley and Dr. Austin. As the mother of a 13-year-old girl who loves science, what experience or individual in your life inspired you to pursue engineering? And the second part of my question is, to the rest of the distinguished panel, how do we inspire and sustain the motivation of Gen Z? Not just the millennials that Sally Jewell referred to in her remarks yesterday, but how do we really inspire our next generation? These are the people who are going to take your legacy and your disruptive innovations and bring their diversity of thought into today's marketplace. And they're so distracted and they're so consumed with so many other, interests today. How do we connect those dots for them so that they can understand what you're doing and the paths that you guys pursued 30, 40, 50 years ago can connect the dots in revolutionary ways for the next 50 years?
What a great question. Thank you. And it also speaks to something that I often hear when I'm here, and that is how does the profession get more respect? How does it get the kudos it deserves? And I've had this conversation over the years with many of you, and I will tell you this, and I think in popular culture, in media, it is gaining a great deal of it. I think that the nuance and the traditional expectation that engineering takes second place to somebody else stays in your memory, but in fact, in reality, the heroes of our economy and our world are engineers. But how do you motivate them? I think it's a great question. So let's start with you and move that way.
Okay, I will start with a couple of reflections of my own life. When I grew up in the inner city of New York, there were not a lot of black female engineer role models. And I fortunately had two parents who valued education and who never told me I couldn't do anything I wanted to do, and just told me I had to be willing to work hard and to go for it. And I think that's really, really key. I think the second person that was really key in my life was the 7th grade math teacher that said, "You're good at this. Don't let anybody tell you you're not. And, here's some great things that you can do with it." And so I think having the encouragement, particularly for young girls, is very, very important. I have a 3-year-old granddaughter who takes my iPad and does things with it that I've never been able to do or replicate. And that's encouraging to me because she has no fear of technology, no fear of, this is too hard or I might, do something wrong. And that's what we have to encourage. So I take every opportunity I can to get out and talk to students, go to elementary schools, because you never know what it is that you're going to say that's going to inspire one young person to pursue the career in engineering. And you have to be exposed to as much as you can. I wish I could say that when I got to high school, I decided I wanted to be the CEO of aerospace. Didn't know anything about aerospace. I knew I liked solving hard problems. And so I started off looking for an area where I could solve hard problems. And when I went to graduate school, I had a professor that said, "Hey, here's a problem that needs to be solved." And voila, the light bulb went on for me. So it's a key issue. It's something that I think everyone in this room needs to own because these are our future leaders. We need our elected officials to be technically, if not savvy, at least comfortable and to understand what engineering does for them. And I don't know that we have that today. Corley?
Well, apart from the fact that I didn't want to clean the chicken house was probably the driving force. But because my parents didn't have even high school educations, and neither did my brother, so I was the first in the family. I really didn't know anything about engineering. I mean, I hadn't even thought about it. And even in my undergraduate career, that was not, I'm a microbiologist by background. It wasn't until actually that my husband and he took his first job at New Mexico Institute of Mining and Technology, and I was a work-study student, and I worked for a metallurgist as an undergraduate on a work-study program. And he said, I'm really interested in this microbiology mining intersection. But I don't know anything about microbiology, and I didn't know anything about metallurgy. And so he was really, I think that was one of the first places that ever motivated me. Frankly, I never ever really thought of myself much as an engineer. I just was doing engineering work and applying microorganisms to mining. It wasn't until I got elected to the NAE that I discovered that I was an engineer.
Go ahead.
So,
any of you who want, I just think this is important enough that any of you who want to comment on it, please do.
in terms of motivating young people, I would want to agree with Wanda. Get out of the way. Let them do their thing, male or female. Encourage their curiosity. Failure's okay, we all know that, but they may not. And the fact is, as teachers and faculty, we lie to our students. We present them 4,000 years of knowledge, crystallized and kernelized, and here's this gem, here's Shakespeare, here's Maxwell's equations, here's whatever. And they think, well, this is the way things, just, it's easy, we'll get to the frontier and we'll be the next whomever. And then they hit that frontier and they realize, my God, I can't move a thing. And then you tell them the next thing, which they won't believe you on after we lie to them, that they can make a difference. They have to be encouraged and applauded for their successes and encouraged with their failures. The second part is, I believe that computers are the worst enemy of deep thinking.
I think he was being ironic. You weren't supposed to clap for that.
It's too easy to run a computer model of something and look at the numerical results and say, here's the way the system behaves. And then you say, are you sure? What if I double this parameter? What happens? Oh, I'll run another simulation. No. Understand what it is you've gotten. So they have to do more than just computation, as we know so well. They have to understand their own results and then try to extend them. But the curiosity thing, I think, is the most important part.
I just did want to say, though, without disagreeing with you, Len, which I never would do, well, not too often, but, you know, I envy those kids the power that they have with computers and so forth. And when we got out, we didn't have that kind of power. But on the other hand, you know, we had fertile technology. It was just ready to blossom at the time that we got out. I think a lot of us were lucky in that respect. And now the world is so much more complex, and there's so many more engineers that I think it's a lot harder to stand up. But nonetheless, in a way, I envy them the power that they have in simulations and working with computers. And some of these kids are really, really great with computers. I mean, it's amazing. You go talk to the kids in school, the grade school, the high school that many of us had the opportunity to do, and you just find, gee, there's a lot of genius out there.
And there's plenty of opportunity in the white spaces. Just shift a little bit off the main thread, and that's where you'll find the gold.
Any of you guys want to respond to that? Well, not the computers versus not computers fight. the how to inspire young people's fight.
Well, I'm a proud father of two daughters, both in college, undergraduate, both in engineering. So when I look back and ask the question, what did my wife and I actually do? And we actually got out of the way. And we did not say, if they had gone to art history or dancing, we would have been fine. So I'm trying to think, what did we actually do? We certainly encouraged them. We helped them with math homework, maybe, I don't know. We did expose them to a few museums, both art museums and the Lawrence Hall of Science, which is quite close to our house. Science Exploratorium in San Francisco. And I suppose it was the mixture of all of that said, oh, maybe I want to try this. And if they decide now that, to hell with engineering, I want to go for art history, fine. But I think, I'm trying to think as to what we did, and I don't think we did anything special except for what parents do. And it comes back to what Wanda was saying is parenting. If you do the right parenting and you have the right teachers, this is one some people choose because they find they're good at it.
This is an issue that psychologists have looked at and, in fact, recently written about. It's interesting that young people generally display an interest in science and engineering at a fairly high rate early on, but there's loss of persistence. And one of the major modulators of persistence is having a mentored experience. The mentoring encourages the individual. This gives them confidence. And there is this feedback loop between confidence and motivation. That in turn motivates them to pursue activities that are STEM-based. But I think a key element that seems to pop up in every analysis and review is that of a mentored relationship.
Thank
Thank you. And I won't ask everybody to respond to everything, but if you want to have a meeting like this in 50 years, it does depend on getting that question answered and figuring out how we're going to have the engineers to do that. And I might have to say, Leonard, it's great listening to you. If I didn't know that you were one of the developers of ARPANET, I think you were Andy Rooney carrying on. Today's kids. Back when I was a kid, there was just one plug. Sir, please go ahead.
So I'm Tom Buttinger from Bioengineering and from the University of California, Berkeley. I have a question for you, Ali.
Oh, my.
This is one that you might not be able to answer very well, but it's a very important connection between biology, engineering, materials, manufacturing, and finance. Suppose
You set me up for failure here.
Coralie Byerly and her husband, the two people that figured out how to extract copper using biology, extracted gold. What would this do to the financial market?
Wow.
That's interesting.
There are so many issues here, the science and the engineering notwithstanding, and that is whether or not gold is going to be the answer for our economy. And I guess that's probably the bigger question. The one thing that gatherings like this remind me of is that our traditional measures of prosperity and wealth are changing by virtue of everything you have all described. It used to be about accumulated wealth and whether you got that from someone before you and how much more you were able to achieve. And yet the new wealth today is from people who have figured things out and created new things with demand. So in fact, I would put less energy into figuring out how to get more gold and much more into that last question about figuring out how to get more engineers. But thank you for the question.
Good answer.
I wanted to ask, I'm Frank Barnes. I wanted to ask a coupled question. Does energy storage fit into the situation with renewable energy? And secondly, how is that coupled to the political process, which in terms of the things I've seen, put the longest part of doing anything in the energy business is getting the approvals and so forth? And I wonder what your comments are on that.
Well, certainly energy storage, if you're going to put renewables in the grid, it could be an immense help. The cost has to come down. For stationary storage, we are about a factor of 4 away from parity with pumped hydro. And so pumped hydro is already being used. It is the majority of the storage that we use today. But if you could bring down the cost to about $100 a kilowatt hour capital cost of storage, and the research is on and it's coming down, then it could be a game changer. And not just for the United States, this is worldwide. So that, I think, when I was in the government, we invested a lot in storage, in R&D, in research, and in mixing science and engineering and coming up with system-level solutions. Your second question was about the time it takes, about the political process. Well, we are here in Washington, and yes, the political process is crummy, and it's stalling. But we still get things done. I'm optimistic. I mean, you got to recall when the Civil War was going on, it could not have been worse in terms of the political process than Civil War. People are killing each other, and yet we passed the law to create the national academies. Yet we passed the law to create the Morrill Act to get the public land grant universities and the railroads, et cetera. So I think, yes, things are not exactly optimal, but I'm optimistic. I think we have to work through the system, get the right people in there to get things moving. And in the long run, you got to take a long-term view on this. Short-term, yes, it's not functional, but I think the long-term, I think the process is, has worked. I would not give up on that.
Over there.
I was quite pleased and appreciative of the talk yesterday about the Dartmouth efforts to integrate engineering with the business sector. So my question relates to, as we have these big and wonderful systems, who makes the decisions that allow a plane to be lost, that allow the pumps to be so low that a nuclear plant can't keep the cooling going after a tsunami, that allows miners to go into coal mines, I suppose without RF tags, so we can't even figure out where they are. To see into the earth, I'd like to see where those miners are, and why don't we? And finally, to lose a well in the Gulf of Mexico and see 5 million barrels of oil spilled. Are these engineers that make those decisions? And if not, do we have enough control on the ethics of our profession to do better? And do we understand well how to handle the whistleblower? Big question, sorry. Anybody?
Oh, but they're great. They're real. I mean, it's questions I asked as a journalist too. We can't find the plane? Are you serious? You can't shut the well off? I mean, it does strike me as interesting that we learn about these market failures in many cases afterward, and they are serious. Now, the good news that some of you demonstrated is that we really have learned from that, but the imagination seems to come a little bit late. So I'm curious. I think that's a fantastic question. Please, anybody who'd like to go at it. Let's start with you, Wanda.
I think the engineering ethics issue, which is underlying your question, is a critical one, and it's something that we don't talk enough about. And when people start focusing on, the return on the next quarter, you get a direction that starts leading toward bad decisions, where they're not thinking about, the global implications of what they're doing and the long-term benefit and objectives of that. I don't have the answers on the whys of the specific issues that you mentioned, but I struggle with that as well, which is, how is it that we fly airplanes with millions of people and we don't have systems on there to protect against that possibility? But I think that one of the things that, I try to talk about when I talk to college students is the ethics that goes along with being an engineer, that you have to be willing to tell truth to power, and they don't always like it, but you have to tell it. And we also have to demand of our elected officials that we expect you to do your job in terms of protecting our society and keeping us safe, and make that a focus that's clear in the decision-making and the allocation of dollars that you have going forward. So I think you're working a very critical and very important issue, and I think that the people in this room understand that. I think there are a lot of people outside of this room who do not.
Please.
Well, we never intentionally send anybody underground just to get killed. That's, but unfortunately, accidents do happen. And what we do is we learn from every one of these accidents. It's unfortunate that any accident has to happen. But we learn from each one of them. And technology indeed has played a very important role to prevent a lot of these deaths. Let me give you just a couple of examples. We now use driverless trucks in a lot of mining operations that are, we've taken the technology from these other people, GPS technology, electronics, and so forth, and we can use this to prevent these sorts of deaths. I mentioned the continuous miner, which is used in underground coal mining today. The number of miners that we used to have to send underground was a lot. With a continuous miner, we have very few people underground, and and I'd mentioned in situ mining as one of the technologies that I believe is important going forward. And one of the reasons I'm an advocate of that, as long as we can protect groundwater and we can protect the environment, I think it's a great technology because we don't have to send people underground. So we use engineering and technology to help us.
Bob.
I just did want to say that I'm very interested in the concept of black swans here. There's a whole new way of thinking about these very low probability events, and they do happen, and they just are not foreseen. And I think that this is a very interesting way of maybe in the future of trying to grapple with what these events are.
So 2 comments. One, there certainly is a failure to instill the notion of ethics in our engineering curriculum. On the other hand, there's a failure on the part of corporations to spend dollars to protect against things that they're not getting a quarterly return on to basically encourage their shareholders. However, of the many incidents you talked about, had there been a proper sensor technology available, some, you mentioned yourself, some of them could have been prevented. And in fact, we're moving very strongly in the world of sensor technology. It doesn't solve all of them, but it certainly will address a number of the issues you raised.
That's an important point. I hadn't drawn that conclusion. These all have to do with sensors. Fascinating. Yep.
I'll just since I lived through the BP oil spill, and to some extent Fukushima, we used to call the Department of Energy the Department of Disasters, because there were so many disasters happening. So a few things. Murphy's Law. Edward Murphy was an aeronautical engineer, and he created, or he at least coined, or something coined after him, is looking at the worst case scenarios. It's not that if something goes wrong, it'll go wrong. It's really looking at the worst case scenarios. And believe me, when we were going through the BP oil spill, I used to send emails, and others to send emails, and say, what's Murphy's Law scenario? And let's make sure that we design for it. And it's a cultural thing. And it's fair to say that when BP was designing or operating, they were not thinking of Murphy's Law. It's a cultural issue. And it really has to come both from the top of the organization as well as the bottom. And there has to be that acceptance that we have to take care of worst case scenarios. Now, that doesn't mean that you don't do anything. There are technical solutions for it, the engineered solutions to do that. And I think it's very important to have that balance between making sure you take care of the worst case scenarios through engineering, but it's not a case that we don't do anything. Then you're stalled then.
Great answers. Robert?
Yeah, I'd just add, one of the things we do quite effectively, aviation industry, is we monitor closely the performance of the equipment out in the field. And if we see something that's unexpected, even if, the passengers, you wouldn't even know that happened, we get to the root cause, for every single one of those incidents. And sometimes some very strange things have happened, and in the course of trying to investigate that, we've learned new things that were sort of unexpected. Like who would have thought if you had fatigue loading on a part of an engine, where it gets loaded in tension from the operation, then held at that level for a while, and then unloaded. The fatigue performance of that material is quite a bit different than if you just had regular cyclic type fatigue. And of course, once we observe that happening, then we're able to change our design codes and everything to prevent that from happening. So in the aviation industry, we're proactive in trying to avoid some failures, certainly the large failures, but even the small ones.
Yeah, but you lost a 777, and nobody can find. Doesn't seem like a small problem.
For CNN, it was an existential problem. This isn't being recorded, right? Sir.
Kishore Mehta from Texas Tech University. I have been working with natural hazards, particularly with hurricanes and tornadoes, and how to mitigate the impact of natural hazards. And we made some progress technologically. The difficulty, as you saw in Hurricane Sandy, is implementation of it. And this is where we are running into trouble with the socioeconomic political system. And my question is, if we make some technological advancement, but how do we deal with, in the next 50 years, social, political, and economic issues such that natural hazards won't be disasters in community?
There's another building down the road you might want to check in with. for that. I mean, it's a good question. I don't know what because the answer doesn't really reside here, unfortunately. I've been covering natural disasters for years. Anybody ever see me out in Sandy, blowing around? It's crazy. It's on YouTube. It does seem that the technologies exist to mitigate most of these things. Sometimes we don't learn about them until afterwards, but we do seem to know how to do it. But deciding as a policy that we're going to do it, other than through code, what else happens? There you go.
Well,
won't be here.
I'll give you one story.
Okay.
So when Sandy happened, the president was directly involved. He asked the Department of Energy to look at availability of access to energy. So gas stations. So some gas stations had power, but no gas. Some gas stations had gas, but no power. So the response to that is very different. So how do you find out which gas stations had power, which gas station did not? And it turns out that Google had a crisis team, and they look at all crises around the world, and they immediately set up a network, and you could upload things, and they can share things. And the Department of Energy relied on that Google crisis team to tell them which gas stations had what. And so I think why am I saying this? So I think there's a good mix of technical, engineered help out here that one could provide. Yes, I completely agree with you that the alignment of regulation, policy, and politics and social, they all have to happen. And sometimes it's not in our hands. But I think it's very important to look at clever solutions that could really help on the ground level.
I'm just finding this out. Now you tell me. And I live right there in Sandy, and I'm spending all my 2 weeks driving around looking for gas, and I don't even know.
Get on to Google.
Maybe that'll change Leonard's mind about the computers.
Because I had no power for my computer either.
Where can I find gas near me?
No. The dog network would tell them where it is.
So, Ali, thank you. A question for Aaron. I agree with you totally on nuclear energy. I mean, Merkel, here's a Fukushima, 70-year-old technology, a 9 Richter scale tsunami. You ought to say, my God, isn't that just incredible that it put up with it? And so her decision is absurd. But anyway, on the issue of so-called climate change, which has been changing for millennia, correlation is not the same as causation, as you know. So you have to establish cause and effect. Scientific consensus is an oxymoron, and models are not data. They're loaded with assumptions and have to be re-looked at, et cetera, et cetera. So the real data we have is 20 years of stable global temperatures, a little bit of cooling, in fact, despite the fact that CO2 has gone up, anthropogenic CO2 has gone up by 10%. That's real data. So before we start spending bucket loads of money on something where there's no real established cause and effect. We know it's a greenhouse gas. We know it traps heat. The question is how much and how big a problem is it? I think it is minuscule. In that, I agree with Dick Lindzen at MIT. We cannot afford...
Got to get a question out of you here.
Well, I'm just saying, do you agree?
I heard you say the question is, and then you said something,
the question
then
is,
you started something else.
Do you believe the cause and effect has been established? And if so, where are the data? I mean, that is about anthropogenic CO2.
Is this a congressional hearing that I'm in?
It could be.
Well, okay.
By the way, Peter Farrell, bioengineering, so I'm not a climatologist.
So how many of you have heard of the Seuss effect by Dr. Seuss? This is not the guy who writes the books. There's something called the Seuss effect. What is the Seuss effect? It's really looking at the isotopic data. Mm-hmm. So the lifetime of the half-life of carbon-14, which is biological, and carbon-14 gets made by cosmological on nitrogen and makes carbon, and that's why carbon-14, and we absorb it. That half-life is about 5,000-something years, 5,600 years or so. So the half-life of all the carbon that is there down below in the fossil, they are all carbon-12. So the Seuss effect is looking at the ratio of the carbon-12 to carbon-14. And that is going up. And so there's a lot of skepticism. Is this human-made or not? It is human-made. That isotopic data tells you that. The question is, do we understand climate change? Do we have the I's dotted and the T's crossed for climate change? The answer is no. Do we understand energy balance? Yes, we do. There's more energy coming in than going out, so it ain't cooling. It's heating. And now, will there be variations? Can we predict where it's going to heat up and where it's going to cool down? The data that I showed, if you actually look at the geographical distribution, you find that there are hotspots happening. You got 2012 was a really hot summer in the United States. People lost livestock, etc. But next year somewhere else, it's like a bubble in a carpet. It moves around. So we don't know all the details, but we don't understand fully. We can't predict the velocity profile of a turbulent flow. But yet we make planes. We fly them safely. And so I think the question is, if you look at the broader picture, we don't understand all the details of climate change. Yes, there's an ocean effect of the temperature that is plateauing. That's the best guess that we have right now. A couple of science papers came out a few weeks ago. But we don't understand all the details. But yet we know it's heating. And there are consequences of that are severe. So we have to take an insurance policy. We have health insurance. We have car insurance. You got to take an insurance policy and do something about it.
All right. Well, if the
Peter, I got to hold you back.
The premiums.
Peter, can he cut his mic off?
Take out insurance.
I got to be strict about that, Peter. Thank you, though. Good to see you again. I'm a bit surprised at the time. This has gone very, very quickly, so unfortunately we're out of time. I thank you for remarkable questions. I thank our panel for remarkable addresses to those questions. I'm going to invite Dan back up to the stage, so don't go anywhere just yet. Thank you.
Really, wow. This has been great. Is this on?
No.
It's not on? Yes, it is on. I'd like to thank the panel very much. I'd like to thank Ali Velci very much for this very, very important forum. I mean, this is actually going to be part of the record of this meeting, and we're going to have this printed, and it'll be in the record of the National Academy of Engineering. So 50 years from now, these people will speak for the future across this whole domain of engineering. And very effectively, very precisely, very focused conversation. I think the historical record of the Academy is really going to be established by this forum today. And I thank you all very much for your efforts in putting this together. And Ali, thank you very much. As always, again, you've done a great job here for us. You didn't talk about the fact you majored in religion in Toronto or someplace this year, but that's all the more important for us. I have two other things to mention. There is many members signed up for the lecture, as it were, or conversation about testifying before Congress, and that luncheon is in the West Court, in the lecture room up on this side. So please go there. Jim Jensen is waiting for you, and remember too that for those section meetings that are being held in the Keck building, the bus there's a board outside that says where those sections meetings will be held in the Keck building, and then there's and probably maybe some of them in this building as well. But the buses for the Keck building will leave at 1:15, 1:30, and 1:45. So it is now 12:35, and I thank you very much for coming to the forum, and I thank you very much for the sections this afternoon as well. It's been a very great time.